Hi everyone! Today we're going to be talking all about how to predict products. And predicting products is just a way to estimate. And we know that sometimes we'll need to make a prediction or an estimate of what our answer is going to be for a couple different reasons. First, we know estimating is always helpful to allow us to check and see if the answer that we get is reasonable. But we also might be asked to make a prediction because we're trying to do a comparison. For example, you might see a question like this. 2/3 times 3/5 is blank 3/5. In a question like this, you're trying to see if the product of 2/3 times 3/5 is greater than, less than, or equal to 3/5. So to figure that out, we need to look at the pieces that are the same and then use the pieces that are different to help us come up with our answer. So to do that, first, look at your ending value. In this particular case, the end value is 3/5. We'll also cross off the factor that's the same. So if my end value is 3/5, I'll also cross off the factor that's equal to 3/5. Next, I need to look at the other factor. In this particular example, the other factor is 2/3. First, I'll ask myself, is that other factor equal to 1? If the answer to that question is yes, then we would say that that product is going to be equal to our end value. In this example, 2/3 is not equal to 1, so I know that 2/3 times 3/5 will not be equal to 3/5. Since I said no to the question, is my other factor equal to 1, I need to now decide, is 2/3 greater than or less than 1? Since 2/3 is less than 1, that means my product will be less than my end value. And that makes sense that 2/3 times 3/5 would be less than 3/5 because I'm multiplying by a number that's less than 1 whole. When I multiply by something less than 1, my answer becomes a lesser number. Let's take a look at a couple more examples of this type. I might also see a mixed number as one of my factors. So for example, I have 3/8 times 1 3/4 is blank 3/8. Again, I'll start by looking at the end value, which is 3/8, and I'll cross off the factor that is the same. So I'll also cross off my first factor of 3/8. Then I need to look at the second factor. 1 3/4 is not equal to 1, so I know that this answer cannot be equal to 3/8. But it is greater than 1. So that means that the product of 3/8 times 1 3/4 is greater than 3/8, which makes sense because I'm multiplying by a number that's greater than 1. We could also see 6/7 times 5/5 is blank 6/7. In this case, my ending value of 6/7 is the same as my first factor, so I'll cross both of those off. Now, my second factor of 5/5 is what I need to use to help me decide. 5/5 is the whole number 1 in disguise. Remember, whenever your numerator and your denominator are exactly the same, your fraction is equal to 1. So that means 6/7 times 5/5 is equal to 6/7. And that makes sense because I'm really saying 6/7 times 1 is equal to 6/7. So definitely be on the lookout for the whole number 1 in disguise. Let's take a look at one more example of how this might come up in a word problem. So we often see these questions when we need to make a comparison between groups or between people. So for example, this question reads, Melissa worked on her math project for 1 3/4 hours on Monday. She worked 5/6 as long on her project on Tuesday. On which day did Melissa spend more time working on her math project? Okay, so let's go line by line and kind of digest this. First, it tells me that Melissa worked on her math project for 1 3/4 hours on Monday. Then it says she worked 5/6 as long on her project on Tuesday. That means if I wanted to know exactly how long she worked on Tuesday, I would need to multiply 1 3/4 times 5/6. Finally, the question sentence asks, on which day did Melissa spend more time working on her math project? So I don't need to find the exact number of hours she worked on Tuesday, but instead I can use a comparison. So if I know she worked 1 3/4 hours on Monday, I can compare Tuesday's amount to Monday without even having to solve. I'll just write one of those comparison statements. So I can multiply 1 3/4 times 5/6 is blank 1 3/4. The product of these two numbers would be Tuesday's time. So I'll use that same strategy. I'll cross off my end value and the factor that's the same, which happens to be Monday's time, and I'll look at the 5/6. Since the fraction 5/6 is less than 1, I know that my answer to 1 3/4 times 5/6 is less than 1 3/4. That tells me that on Tuesday she worked less time than she did on Monday. But let's go back and check the question sentence to see what they want us to really answer. The question sentence says, on which day did Melissa spend more time working on her math project? Since I figured out that on Tuesday she spent less time, that means on Monday she must have spent more time. So I would answer this question by saying she spent more time working on her math project on Monday. So that's a way that you can use estimation and predictions to come up with an answer to a comparison question or a relationship word problem. Thanks for watching.